Okay, so let us start. So I'll just turn on my camera. I hope you are able to hear me. Can anyone just let me know whether they are able to hear me or not? Hello?
It is audible, sir.
Okay, thank you. Okay, 1 minute. Yeah, okay. So yeah, I hope you are able to see me also. So welcome everyone to this session. This is basically um a live session conducted by NPTEL on every such courses which are organized every semester. So in these courses, we will be looking at some typical problems of last past year's assignment, and we will try to solve them. And obviously, this will help you in solving the current assignment questions and also help you to sit for the final exam which will gain you a certificate at the end. So yeah, this is all about it. 1 minute. Yeah. Okay. um, so we will obviously go through the past assignment questions, and this is of course a 2 hour session from 7 to 9 every Monday, and this will be held for every 12 assignments. I mean, since this is a 12-week course, so there will be 12 such live sessions corresponding to 12 assignments. And every week we'll be looking at assignment 1, 2, 3 till 12. Okay. And this is a very basic course. So the network analysis or circuit theory system. So this is a very basic course of the BTech level, and you can expect plenty of problems where you have to solve the equations and get the values of current, voltage, resistance, etc. And obviously, I expect that you will be looking at the lecture sessions, the lectures which are actually uploaded in the in the portal, and after that you will be trying to solve the assignments, and obviously you should also join this session which will help you to solve the assignments. Okay, so regarding the material that we will be providing, will be using in this curriculum. So this session is being recorded, and you will be able to avail this session in my YouTube channel. So the link to this video will be shared, and also the material that I will be using for teaching, that will also be shared to with you. So NPTEL will obviously share this, and you can access that and look at this to solve the problems of the current assignments. So small thing about me, so I am Shobik. So I am a PhD scholar at the Department of Electrical Engineering at IIT Bombay. And okay, so 1 minute. Okay, so I hope you are able to see my screen, see the PDF also. Could anyone just let me know whether they are able to see the screen or not? Hello. Can anyone just let me know?
Visible, sir.
Okay, fine. Okay, thank you. Also, just if you have any doubts, so I'll be stopping after every question. If you have any doubt, just raise your hand. There is a raise hand option. I just saw two or three people raising their hand. So if you have any doubt, just raise your hand. I'll unmute you and you can then ask the doubt. So without further ado, let us start solving the problems. So this is based on assignment one of the same course which was run in the previous semester. So as I told you, since there are 12 assignments, there will be 12 live sessions corresponding to every assignment. And looking at these, you can solve the questions of the current assignment and then get the answer. So this will of course help you. So that is what is the purpose of these live sessions. So as to enable you to fetch better marks in the end exam. Okay. So this first assignment, this is based on nodal analysis and mesh analysis, which is the basic building block for solving any circuit theory problems. Now let us solve the questions. So the first, so this question is basically a common data question for question number 1 to 6. So this is the circuit. I'll just maximize the screen a bit, zoom in so that you are able to see it. Okay. So this is the circuit that we are given here. Now this is an independent current source. There are three independent current source of 4 ampere, 7 ampere, and 2 ampere, and there are three resistances that are used, and of course there is a independent voltage source. The magnitude of each of these are also shown in the diagram. Now you have been asked sorry, you have been asked to find out the value of this voltage V1. Okay, so this is basically the voltage of node V1. So what is node? I'll tell you. People are joining. Yeah. So you have been asked to find out what is the voltage at this node, and this node. Okay. And there will be other three questions. So at first we will be addressing these three questions because these are the main, these are the main parameters for these questions which you need to find out. Remaining three questions you can easily solve once you determine each of these parameters. And of course, while solving nodal analysis questions based on nodal analysis, there is a reference node that you get. So basically, what is a node? As you know, node is basically a terminal of the circuit where two circuit elements are connected. For example, if you see this node, this where this V1 is written, you see that there are three different circuit parameters that are connected. So one is this independent current source of 4 ampere, then there is this 7 ampere source. Okay, so there are four elements basically. I'm sorry. So there are two current sources of 4 and 7 amperes, and there are two resistances of 3 ampere, 3 ohm and 4 ohm. Similarly, this is also a node, this is also a node, this is also a node, because there are different circuit elements that are connected to this. Now, I mean this reference node. What is this? So normally, if when you are solving the questions, this reference node, I mean a particular node where it is written that this is a reference node, it won't be written generally. So since this is the first problem that you are solving in this assignment, so for your help, for your benefit, for a kind of hint, you may say this is written as a reference node. Now basically, in nodal analysis, you probably know that while solving any questions, we have to treat a particular node as a reference node. So basically, at a reference node, we assume that the voltage at this node, so let's say this is V0, okay. So let's say the voltage at reference node is V0. So we treat the voltage at reference node to be 0. So that is why the voltage at this node is 0, and hence this is called a reference node. Okay. I hope this thing is clear, and just hold on for maybe the first question, finding out V1. Obviously, once we find out V1, we'll be able to find out V2 and V3. After that, you may ask the doubt you have. So just hold on for that. You may raise your hand, and then you may ask your doubt. So people are joining in. So guys, please try to join. Whoever will be joining every week. So please try to join sharp at 7 because it's already 7 past 12 in my watch. Okay. So now we'll be solving the problems slowly, and I have solved the problem for you beforehand so that we are able to look at another problem after the end of this assignment. So that is why basically I have solved this beforehand instead of solving in front of you. So this is the diagram that was given to you, circuit diagram. So for your reference, I have again drawn it here, and uh, I have marked something. So this the voltage at this node, and this node was already given, right? So this was V1, V2, and V3 as per the question. Now I have just assumed that through this line, so from V2 to V3, we assume that a current I, capital I, will be flowing. So that is why this value is given. So I in this direction, right? In this line. So from V2 to V3, this current I will be flowing. And here, of course, I have marked the nodes as you may see, and I have written that nodes are marked from 1 to 4. And as per the question, so they have just helped us to proceed. So we can take the reference node to be the node 4. And as I have told you that in nodal analysis, one of the node, you the voltage at one of the node, you have to take it as 0. So basically that is grounded, so you ground the system, right? So that is why voltage at node 4 is taken to be 0, and therefore we can write that V4 equals to 0 since the voltage at this node is 0. So this is simple. Now um, we know that at any node, so incoming current would be equal to outgoing current. So the current that is incoming, so the current that is entering a particular node, that would be equal to the current that would be leaving the node. So this is basically following the rule of KCL, Kirchhoff's current law, right? So this is nothing but KCL, which is being followed at every node. So keeping this in mind, we can start solving the problems. So this basic formula would be followed at every node. Incoming current would be equal to outgoing current. So let's take node 1 first. Now at node 1, what is my incoming current? So this is my node 1 basically, right? I have marked it as this 1 here. So this is 1, node 1. Now my incoming current is 4 ampere, right? Because this is entering the node. So that is why I have written here 4. And I am assuming that at every node my flow of current is going outward. So it is not entering the node, it is leaving the node like this. So it would be so basically after this node, the current would be flowing through this 3 ampere towards V2. Then this 7 amperes, so obviously it is given, and the direction is also there that it is flowing from V1 to V2. And from V1 to V3, the current would be flowing something like this from V1 to V3 in this direction, right? So that is why we have three outgoing currents, right? One from V1 to V2, again one 7 ampere source from V1 to V2, and then another one from V1 to V3, right? So that is why we can write this. So what would be the current flowing through this line? So from V1 to V2 through 3 ampere, it would be nothing but the voltage at this terminal minus the voltage at at this node minus the voltage at this node divided by the resistor value, right? So which is 3 ampere. 1 minute. Yeah. So this would be nothing but voltage at node 1 minus voltage at node 2 divided by the resistance value, right? So which is 3 ampere. So using this you get this one term here, one, and another is 7 ampere. It is directly given, right? So it is an independent current source, as I told you. So this would be nothing but 7, and another is this thing, right? So here the current is flowing from V1 to V3 through resistance value of 4, right? So this would be nothing but voltage at node 1 minus voltage at node 2, basically the potential difference, right? Voltage difference or potential difference between these two nodes divided by the resistance value. So you get a thing here. Now you need to solve this. So here, since this is the first assignment, I have solved this in detail, so that you know, because these are kind of large equations that you will get. So basically here, as you can see, there are three unknowns, right? We don't know what is the voltage at node 1, 2 and 3. So you will be getting three equations, and you need to solve them to get the values of each of these node voltages. So you need to be very careful when you solve this, because some kind of calculation mistake, you know, it may result in a wrong answer. Keeping that in mind, I have solved this independently, and I mean, you can obviously do solve it on your own and then match the answer if you want to. Okay, so now after solving this, we get this equation in so a equation where we have V2, V3 and V1, all of these node voltages, and we get our first equation. Now, okay, we'll come to node 2, but let us now focus on node 3. 1 minute. Okay. Okay, so now let us look at node 3. So I'll just, yeah. So this is my node 3, right? This is my node 3, and I mean, you can choose the, you know, the direction of current, in which direction the current is flowing as per your convention. So according to that, the sign, the direction of the current will change, right? So what I have assumed here, my current at node 3 would be something like this. So this may be different in your case, but this is what I have followed, and please carefully listen to this. So at node 3, what I am assuming that one of my current is flowing from node 1 to node 3 in this way, right? From V1 to V3 via resistance 4. So guys, please try to join at 7, because you know, these are breaking the my flow in which I'm talking. So kindly please join sharp at 7. Whoever wants to join the live session from here on, please do that. Okay. So we were looking at node 3. Now I am assuming that my current is flowing from node 1 to node 3 via resistance 4, resistance of 4 ohm. So this is right. So here I get one value. So basically the potential difference between these nodes, that is V1 minus V3 divided by 4. 1 minute. Then we have this current. So this is what I told previously, that I am assuming that my current that is flowing from node 2 to 3 between through this line, right, where there is a 5-volt source. So I'm assuming that the current that is flowing through this path is I. So as you can see, the direction is from 2 to 3, right? So therefore this current is entering node 3. So there is plus I here, and of course there is a current that is flowing to 3 from node 4, that is our reference node, from 4 to 3. Therefore these are all flowing into node 3, right? So these are all nothing but incoming currents. One is flowing from node 1 to 3, another is flowing from 2 to 3, another is flowing from 4 to 3. Therefore we get this equation. this term on the left hand side, sorry. And the other thing is this resistance 2, right, which is connected between 3 to 4. So we are assuming here that the all of these currents that is flowing from 1 to 3, then 2 to 3, and of course from 4 to 3, this would be flowing from 3 to 4 through this resistance 2. So therefore this is my outgoing current, because this is flowing from, I am assuming that this is flowing from 3 to 4, not 3 to 4. So this is my outgoing current. So this is equal to V3 by 2. So this is my second equation. And we also have this note 2 here. So here, okay, so here we also can frame the equation in, I mean, in similar way. So this would be nothing, but this would be very simple. So my current would be flowing from node 1 to 2 in two paths, right? One from this through this resistance of 3 ohm value, and one through this current source of 7 ampere, right? So that is why we are getting V1 minus V2 by 3 plus 7, right? So these are my two incoming currents, right? And my outgoing current would be what? One would be flowing through this terminal, so this resistance of 5 volts, sorry, 5 ohm to the ground terminal, and the other through this path, right? So this would be nothing but I. So therefore, V2, so this would be what? V2 minus 0 by 5, right? So basically V2 minus 4, V4. So V2 minus V4. So I haven't written V4 here, because why? We considered 4, node 4 to be 0, right? So voltage at node 4 was taken to be 0, since this was a reference node. So that is why I haven't written 0 here or V4 here, just to simplify the things. And obviously this I is there because this current is flowing from node 2 to node 3, right? So these are my outgoing currents. So now we have these three equations. So basically after this you try to solve these three equations. So what I did, as you can see here, we have this I term here and obviously this I term here. So what I did, I replaced this I. So I framed the equation 3, and I replaced this I in this equation. So what I did, replacing I from 3 in 2. So using this, I got this equation. So this is that is why I was saying. So as you can see, these are, pretty large equations, and you need to solve them very carefully. So one silly mistake you do at any point, the answer would be wrong. You won't arrive at the right answer. So that is why please solve them very carefully, and using a cool head while you are doing the assignments. So now we get this equation number 4 after replacing I from equation 3 in 2, and we get this equation number 4. Now what I am doing, I have written replacing V1 from 4 in 1. Okay. So let us look at equation number 1. So this was my equation number 1, and here what I did, I framed the equation in such a way that I have written V1 in terms of all my other parameters, right? So 35 V1 equals to all of these. So I am just replacing this V1 in equation number 1. So I am just replacing it here, right? So this would yield me equation in terms of V2 and V3, right? So when I do that, this is what I get after solving this. This is what I get. So 60 equals to 5v3 plus 2v2. Okay. And we have another equation. So if you look at this node here, if you look again carefully look at the diagram. So this line here between 2 to 3, node 2 to 3, there is a 5 volt voltage source connected, right? So basically we can frame a small equation using this. So what would be V3? V3 would be nothing but the potential at node 3 would be nothing but the potential at node 2 plus this voltage source, right? Plus this 5 volt source, because so this would be nothing but V3 equals to V2 plus 5. Now You may say why not minus 5, right? It could have been v3 minus v3 equals to v2 minus 5. No, why not minus 5? This is because, guys, just look at the I mean the direction in which this plus and minus is there, right? So this minus is pointing towards node 2 and this plus is pointing towards node 3, right? So therefore, I mean, looking at this, we will say that the potential at node 3 is higher than potential at node 2, right? Because this plus is pointing towards v3. Therefore, we will say that my potential at node 3 is higher than potential at node 2. By how much value? By a value of 5. Therefore, we write this equation that, you know, V2, I mean, basically V3 equals to V2 plus 5. So V2 plus 5 equals to V3. So therefore, we get these two equations where we have V2 and V3. And when we solve this, see, we easily get our value. So V2 will be equals to 5 volts and V3 will be equals to 10 volts. So once you get these two values, you can easily solve equation number 1, which we saw earlier, and you can get the voltage of V1. So node voltage V1. So using this, we solve the first three questions. So they were asked us to find out what is the voltage value at node 1, 2, and 3. So these voltage values are 2, 5, and 10 respectively. So this is the first three questions. After that, there are another three questions. So I'll stop here and just ask you guys whether you have any doubt. So I'll try to, clarify the doubts if you have any. So yeah, so now you may. Okay, so I already see a raised hand. Just a minute. Yeah, Himanshu, you may speak.
Sir, can I use the super node V1, V2, and V2 between V2 and V3?
Yeah, this is a super node basically. Yes.
Yes, sir. And then, sir, I 7 ampere and parallel 3 ohms. Can I doing source transformation?
Yes, of course, you can do. You can do a
Yes,
similar
sir.
similar thing here also. 2 and 2 ampere. You can do that.
Yes.
Yeah, of course you can do that.
Yes.
I
Yes,
mean,
sir.
I didn't do
Sir,
that because, yeah, go ahead. Yeah.
yeah, sir, if I do super nodes and source transformation, then the equation may be solved no long eventually very short.
Okay, I didn't get you properly, but I think what you're trying to say that the equations may change, right? Once you do a source
No, sir.
transformation.
E- yes, equation same, but the conventional process is very short. No longer process. Only three equations, easily three equation find then V1, V2, and V3 value we get.
Yes, I agree. But see, I didn't do that because this source transformation may be used in the next assignment. So I didn't do any kind of changes to the circuit, right? But you can obviously do that. There is no problem. You will arrive at the right answer only.
So, can I get the all questions answer through
Yes,
you?
you
Because
will
sir,
get it.
can I match that? Okay, sir.
Yes,
Thank you, sir.
yeah. I mean, you will be getting this material which I'm using for teaching, and also this recorded session also. So this would be provided to you by NPTEL after the end of every week.
Okay,
Yeah.
okay, okay. Thank you.
Okay. Okay. So any other doubt anyone has? He or she can raise her hand, his or her hand. So you will be receiving these materials and also this video via which I'll be uploading in a YouTube channel. And Okay, so if you also have any doubt while you are, watching the videos on YouTube, you may write your doubt in the comment section there. I will try to solve that. I'll try to address that in the comment section only. And the main motive of, uploading this live session on a YouTube channel is that somehow some students may miss some of the sessions. I mean, this is basic, very basic course, BTech level course, maybe first year, second year course, and we expect that there would be a lot of registrations, right? So it may not be possible that you will be joining every live session. So that is why you can always see these YouTube videos and then post your doubts in the comment section. I will try to solve that. Okay. So, if you don't have any doubt, we will proceed to the next three questions. Okay, so,
Yes,
yeah,
sir. Proceed.
okay, 1 minute. Okay, so I'll just zoom in. Um, Now in question 4, they have asked us to find out what is the value of I. Now these three questions are very direct questions because you have solved the lengthy part. So these are very direct questions. You will just have to replace some values here and there and you will get it. So what is this current I? So now what is I? We need to go back and look at the circuit, right? So this is my I. If you see here, I'll just zoom in. So this is my I, right, which is flowing from node 2 to this reference node or my zero voltage node. Yeah. So this is my I here, and this is nothing but V2 minus 0 by 5 ohm resistor, right? Minus 0 by, again, this is my reference node. So now if we do that, so this is what I have exactly done here. So V2 minus 0 by 5, the value of V2 we just found out. This is 5 volts. So my resultant current is 1 ampere current, which is my answer. And I hope this is very basic thing. I hope this would be clear. Now, what is the question number 5? So find the electrical power delivered, supplied, generated, that is other forms of power converted into electrical power by the 4 ampere source. So here these are three questions which are very basic. Okay, yeah. So what I was telling is that 1 minute. Yeah. So here, don't look at this generated term. So you may just think that what is the electrical power being, delivered or generated. So this thing supplied or generated, these are very same things, right? So is it consuming the power or is it delivering the power? That you need to find out, right? So if it is consuming the power, then there would be a minus sign, right? Because somehow it is accepting the power. So that is what is the meaning of absorbing power, and delivered means it is obviously generating some power, right? So that would be plus. So, right, we need to find out the electrical power which is being dissipated or accepted by the 4 ampere source. So, what is our 4 ampere source here in the diagram? My 4 ampere source is this thing, right? This independent current source which is connected between node 1 and 4, right? So hence what would be my power that is being dissipated? So for the time being, I am assuming that my 4 ampere source, our 4 ampere source is actually dissipating the current. So it is delivering the power, right? So that is why I am using the term dissipating. So it is dissipating the power. So let's say my 4 ampere source is dissipating some power through it, and it is connected between node 1 and 4. So therefore we need to find out what is the voltage difference between this 1 and 4, and just multiply that with this 4 ampere source. That would do it, as simple as that. So we know what is the voltage of node 4. So this is 0 volt, and we just calculated what is the voltage at node 1. So this was nothing but 2 volt, right? So as you can see, the power, as I told you, I am assuming that it is dissipating the power. So power dissipated by 4 ampere source is nothing but the current into its node voltage, right? The voltage difference across the ampere current source. So this is nothing but V1 minus V4. We obviously assume that V4 is 0, and we calculated what is V1. So this is nothing but 4 into 2, which is my gives the power, which is 8 watt. So since this is a plus sign, so there is no negative sign here. Hence we will understand that this is dissipating the power. So or it is delivering the power to the other terminals of the circuit. So my power dissipation by the 4 ampere source is 8 watt. So this is question number 5. 1 minute. Yeah. And finally, this is the last question of this part is find the electrical power. Again, this thing. So what was the 2 ampere current source? It was connected between 3 and 4, right? Yeah. Node 3 and node 4, right? It was connected in this way. So you need to again find out what is the potential difference between node 3 and 4, right? Uh, so 1 minute, yeah. So this is again very simple. So potential difference between node 3 and node 4. So this is obviously 0, and you found out that the voltage at node 3 is 10 volts. So this gives us 20 watt. So this is what my power dissipation is. And mind you, I am writing three potential difference between node 3 and 4, and not between 4 and 3, right? I mean, the direction you need to consider here, right? Because you are calculating what is the potential difference between 3 and 4, right? Therefore V3 minus V4, right? If you find out V4 minus V3, it would be negative, right? So that is why I am assuming, as I told you, I am assuming that it is dissipating the power. That is why we are getting a positive value, not a negative value, right? So if it was if I was calculating between 4 and 3, that is potential difference between node 4 and 3, right? So this would be V4 minus V3, right? So 0 minus 10, right? Therefore it would be 20 minus 20, right? So it would be accepting that power, not generating or not dissipating the power. So in this sense, you need to solve the questions. I hope this is clear, these three questions. So if you have any doubt, you may just raise your hand.
So,
Yeah.
so if we want to find the power generated or delivered in 5 volt source, then what I do?
So see, basically, you need to find out what is the current flowing through this node, right? Because this
Yes.
5 volt is connected between node 2 and 3, and you have this
Yes, sir.
current I flowing through it,
Yes,
right?
sir.
So you need to find
I
out
into
what is the
5.
value of I. Yeah, exactly. I into 5. And
Oh,
we found out this, right? So this was the equation of
yes.
I.
Okay.
Yeah. So
Yes, sir. No, sir. Clear, sir.
yeah, okay.
Okay, thank you, sir.
So any other doubt anyone has? If not, we will go to the next question. And again,
No, sir. Next.
yeah, so please try to unmute yourself. If I say, I mean, if you have any doubt, we will try to solve after the end of every question. or at the end of every session. So please just don't unmute yourself. Okay, so again, we will be, looking at every assignments of every week, and these materials would be provided to you. Probably, I don't know when NPTEL provides, but I'll try to upload it by today night only, this video. And if you have any doubt in the material, you may try to, post your questions in the comment section. I will, uh, address those questions. Okay, so now let us go to the, if anyone doesn't have any doubt, now let us go to the last part. So this is the circuit here. Just zoom into it. Yeah. So this is the circuit here. And so these are some common data questions, obviously. So these are basically from 7 to 12. So in every assignments, you will be expecting around 10 to 12 questions per assignment. And okay, so the previous problem was based on nodal analysis, and this would be based on mesh analysis. Now again, as one student was mentioning that he may use a source conversion and then solve the question. You may certainly do that, but since this is a basic preliminary first assignment, so that is why I am just going by the rules and not doing anything special, doing source transformation or something like that. And second is that since they have asked us to find out the answer, solve the question using mesh analysis, so that is why I'm using the mesh analysis here. You may use nodal analysis also in the question, because in this type of questions you just need to arrive at the right answer, right? You don't need to solve show the process to them, so you just need to arrive at the right answer. And you can use either nodal or mesh analysis to arrive at the right answer. So you may use either of these, but I am going as per the convention. Okay, so this is our circuit here. As you can see that there are two current independent current source and two independent voltage sources, and there are four resistances, right? The values of these are mentioned here. So as you can see that there are four meshes, right? So what is a mesh? Mesh is a basically closed circuit through which a current flows, right? So this basically there are four nodes here, not five nodes, sorry. There are five nodes which I have marked in green here, right? So I'm sorry, this would be five also. I just forgot here. So there would be five nodes, one, two, three, four, five, and there are four meshes, one, two, three, and four. Now my numbering convention I have chosen in this way. Yeah. So there are some this small intermittent problem in my connection. So please, I'm really sorry for that. Yeah, as I was telling, there are four meshes, one, two, three, four, as I have marked, and we need to apply Kirchhoff's voltage law, right, to each of this mesh. I hope you know all of this because these are very standard conventions. KCL, KVL, you must have learnt in your plus two level. So you just need to apply this here, right? So, okay, so we'll just start solving each of this mesh here. And now, yes, before solving this, I have written two equations which are really very important before we solve these problems. So if we consider the first mesh here, right, you see that I have shown a current in this direction, right, in clockwise direction here, in this direction, clockwise direction, which I have written as I1. Now this mesh here, mesh 1, already has a current source which is not involved. I mean, it is independent of other nodes. We can assume that it is independent of the other nodes here, right? sorry, mesh here. It is independent of mesh 2, 3, and 4. So therefore, we can say that the current which is flowing through this mesh here, it is nothing but this current only. So the 2 ampere source, right? So therefore, I can write that this I1 is equal to 2 ampere, right? Now, so this was one. The other thing is this. So if you look at mesh 3 and 4, this is what is the direction of current that I have chosen. So I have chosen the direction of I4 as per the minus and plus terminals of the 10-volt source, right? So it is minus is here and plus is here. So I will be choosing the I mean, based on that, I will be choosing the direction of current in clockwise direction, right? So therefore, this is again this direction I4, and of course this is my 20-volt source. Now looking at this, um, so here I have chosen my current direction in anti-clockwise direction. So I3 is basically in anti-clockwise direction. So I mean, a very critical point here is that once you set the notation of the current and voltage, now you need to, sorry, current, while you are solving this mesh KVL questions, you need to maintain the direction of the current all throughout the problem. Because if you do any changes, there would be, changes in minus plus and minus sign, and therefore you may end up again in the wrong answer. So these are two very careful considerations you need to maintain here. So once I have chosen the direction of current here, I can write I4 and I3 in terms of this 3 ampere source, right? So this is basically, you can say this 3 ampere source is between my I4 and I3, right? So, I mean, you can say that looking at this 3 ampere source, this I4 is also in direction of I3, right? And this, sorry, 3 ampere source. And this I3 is also flowing in the direction of this 3 ampere source, right? So from node 3 to 4, right? You can see this clockwise direction. It will go in the direction of this I3, 3 ampere, and also this 3 I3 would be going in the direction of 3 ampere source. Therefore, we can write this equation that I3 plus I4 equals to 3 ampere, right? So if I would have taken this in again in clockwise direction, so since this is in anti-clockwise direction, then my equation would have changed, right? So this would have been I4 minus I3 equals to 3 ampere, because you can clearly see that I3 would be flowing against in the direction opposite to 3 ampere source. So therefore it would have been I4 minus I3. So these are the basic things which you need to be very careful while you are solving this kind of questions, right? So so just hold on to your doubts. After we solve these two questions, I will be addressing the doubts you have. Now mesh one. So mesh one is nothing but this, right? Okay, so this is just hold on. Um, Okay, so I am sorry, I'm really sorry. So this won't be mesh one, this would be mesh two, right? Because there is a voltage source here. This would be mesh two. So since there was no voltage source value, I was very confused why I haven't written this 10 volt. So I'll correct it. I'm very sorry. This would be mesh two. Okay, I'm really sorry. This would be mesh two. This would be mesh two. This mesh. And I mean, from this mesh, we are getting that I1 equals to 2 ampere, right? I'll correct this before I upload this material on the internet. So if we solve this mesh 2 here, this is the current direction of the current I2 that I have chosen. So it is basically flowing in clockwise direction. And see, so we have these three resistances, right? 20, 10, and 5, and I2 is flowing through each of these, right? So this would be nothing but 10 I2 plus 5 I2 plus 20 I2, right? So I have 35 I2, and again my I3 that I have chosen here, so it is in the direction of, it is its direction is same as that of I2, right? So as you can see, um, uh, 1 minute. Yeah, so I mean, if you look at this resistance, 5 ohm resistance, you can see that I3 is also entering from this negative terminal and going out from the positive terminal of V2. And similarly, this I2 also, right? It is also entering from this negative terminal and in exiting, I mean, going out from this positive terminal, right? So that is why this plus sign is there. So this is 5 I3. And why this minus sign is there? Because this I1 and I2, its direction is completely different. I mean, it's opposite when you look at this 20 volt 20 ohm source, right? So this is entering from this positive sign, positive part, and entering from the negative part, and this I2, it is entering from this negative part and exiting from the positive part, right? So that is why this minus sign is there, minus 20 I1. So based on this, basically the conventions matter, and of course, since there are no voltage source here in mesh 2, so that is why this 0 is there. So this is, I hope this is pretty simple. It is understandable, and I'm sorry, this would be mesh 2 again. So once you do this, you arrive at this equation. And of course, as we saw earlier, that I1 is 2 ampere, right? So we get this. So this would be 8. So 4 into 2, basically 8. So this would be 8 volts. And we get our second equation. So we assume that this is our first equation and this is our second equation. Now we are left with this two meshes, right? 3 and 4. And what I have done, I have taken the whole mesh. So I have just ignored this 3 ampere source. I have taken this whole mesh here, and that is why I have written taking mesh 3 and 4 together, right? So here we have these two um, voltage sources here, and if you see the this plus I mean this convention of the voltage source are in the same direction, right? So basically this plus is connected to this minus, and this plus is connected to this minus. So therefore this would be nothing but but 10 plus 20, right? Since they are in the same direction, they are connected in the same way. So this is 10 plus 20. And of course, I mean, using the same analysis, you can write this. So 20 I4 minus 5 I3 plus I2. So, and obviously there would be no I1, right? Because, there are no resistances connected here where, I1 would also be flowing, right? So say, therefore, there is no I1 term here. So after this, you saw get this equation number 3, and simply what I have done here. So we got this equation earlier. So I3 plus I4 equals to 3 amperes. What I did, I replaced the value of I4 from 1 in 3. So this is what I did. So I4 would be 3 minus I3, and we solve this, and we get this equation number 4, right? And now we have equation 2 where we have I2 and I3, and we have equation 4 also where we have I2 and I3. Now when we solve this, we get the required values, right? So I3 is 1 ampere and I2 is also 1 ampere. And of course, we know what is I1, and we can also calculate, once we know I3, we can calculate I4, right? So I4 would be 3 minus 1 ampere, right? I3 is 1, so I4 would be 2 amperes. And then we finally calculate what is V1 and V2, right? So what is V1? We again need to go back to the question. So what is V1? V1 is this, right? The potential, the potential, not the potential difference, the potential or the voltage across the 20 ohm resistor, right? So you need to be careful about the plus and minus, right? So this, what would be this V1? V1 would be 20 into I1 minus I2, right? So because this I1 is entering through this plus terminal and I2 is entering through this minus terminal, right? So that is why V1 would be 20 into I1 minus I2, right? So that is what we have written here, 20 into I1 minus I2. So this would be 2 minus 1 ampere, and 20 volt would be your answer. Similarly, what would be V2? See, look at the the plus and minus signs here. So V2, through this V2, both I2 and I3 was entering through this negative terminals, right? Into I2 minus, minus of I2 plus I3, right? Because this was entering through the negative terminals. So this would be V2 equals to 5 into minus of I2 plus I3, right? That is why this minus sign I have obviously taken outside, and this would be minus 5 into I2 plus I3. So this would be minus 10 volts. So these are the two answers, that answer to the two questions that was mentioned here. I hope this was clear. So now you may ask your doubts. If you have any, just raise your hand if you have any doubt. And obviously I'll correct this. So this would be mesh 2. And here there are 5 nodes. I'll correct this. Okay, yeah. Yeah, Himanshu, go ahead. You are unmuted.
Sir, please repeat the node taken loop 3 and loop 4 equations.
Okay, yes. See,
Okay.
this node 4, not 4, this is not node, this is mesh, huh? This is not node. This is mesh
Yes,
4 and
miss.
this is mesh 3, right? So see, this mesh
Yes.
4 and mesh 3, these is being separated by this current source, right? This 3 ampere current source,
Yes,
and it is
yes, sir.
pointed from node 3 to 4. And once you look at the direction of the flow of this current, right? So this is entering, I4 is entering 3 ampere source, and I3 is also entering the 3 ampere source. So therefore I wrote I3 plus I4, right? Now what I
Yes, sir.
did, I mean, we in mesh analysis, what you can do is that you can, when you have a current source in between two meshes, right? So exactly we have this current source in between mesh 3 and 4. We can just ignore this current source, because we have this equation here, right? We can use it later. So what we will do, we'll just ignore this current source here, and we will try to solve this whole mesh, right? So between 2, 5 and 4, we'll just ignore this 3 ampere source, and we'll try to solve this whole mesh, right? So here, once you look at this mesh here, total combination of mesh 3 and 4, you see that there are two voltage sources, right? Which are obviously pointing, I mean, in the same direction, right? So, I mean, how do you see that? Because this plus sign of 20 volt is connected to this negative terminal, right? I mean, if you just ignore this resistance, so it is pointing towards this negative terminal of 10 volt, and this plus sign of 10 volt is connected, pointing towards this minus sign of the 20 volt, right? So therefore, these are
Yes.
connected in the same direction. That is why I wrote 10, 10 plus 20, right? So 10 plus 20 would be equal to what? Would be equal to the values of the current that is flowing through the, I mean, sorry, the potential, the voltage across the different resistors. So that is what basically KVL says, right? So this would be nothing but the voltage drop across the different resistors. So what resistances we have? We have two resistances. We have 20 ohm resistor and 5 ohm resistor, right? So if you see, we have, so I have written here, so this is 20 ohm resistor, and this is, so if we take 5 common, we have this 5 ohm resistor. Now um, you need to look at this, yeah, okay, so just look at this equation. So we have this 20 ohm resistor and we have this 5 ohm resistor, right? So see this 20I4, how is it coming? Because see this 20 this I4, we if you just look at this I4, we there is only one resistor that is present in mesh 4, right? So and this is flowing in the direction of the convention, right? So I mean it is supporting the flow of the current through the two voltage sources, right? So 10 volt, right? So it is that is why we wrote 20I4, not minus 20I4, right? And the other thing is this 5 ohm resistor, right? And this through this 5 ohm resistor, so through this 5 ohm resistor we have two currents flowing, right? So this is I2 and I3, and obviously these are flowing in the same direction through this current source. But if you see here, this current source, this I3, this is entering from the positive terminal of the battery, or the my voltage source, right? This is entering from the positive terminal and leaving the negative terminal. So that is why we wrote minus of this 5, right? And obviously this would be minus 5 I3 plus I2, since this is entering I mean the direction of current through the resistance of 5 ohm is same. So that is why I wrote minus of 5 of I2 plus I3, or I3 plus I2. So using this you can frame this equation.
So not clear, sir.
Which part is not clear?
No, so
Which,
not all parts are clear. Then I get the answer also.
no, you understood, right? This 10 plus 20 you understood, right? How I
Yes, sir.
arrived at this. Okay, so
Yes,
this
sir.
20I4 you also understood. Why not
Yes,
minus
sir.
20I4? Why not minus 20I4? Can you please tell me? Why I wrote 20I4 or plus 20I4, not minus 20I4? Why?
Because in the resistance voltage is dropped. Then, sir, the current entered in positive terminal and leave in negative terminal. We always take second terminal. So then we 20. But, sir,
Yes.
according to KVL, all voltage source in loop equals to zero. So then, sir,
Yeah.
if energy delivering, then the supplying is equal to dissipated. Then, sir, then we then we take an opposite side of source, then it take positive sign for
Yes.
20i4.
Yes, so if you understood that, then this is easy, right? So that is why I wrote 20I4, right? Because as you told, see, through any voltage source, current always leaves the positive terminal. I mean, enters to the negative terminal and leaves from the
Yes,
positive
sir.
terminal, right? So if you look at this I4, it is doing the same. It is leaving from this positive terminal, right? It is flowing in the clockwise
Yes, sir.
direction. So that is why this 20I4 is there. And if you look at
Yes.
this I3, it is entering from the negative terminal, right? Sorry,
Yes, sir.
entering through the positive terminal and
Positive.
leaving through the negative. That is why this minus sign is there. And
Yes.
this I2 is also there, which is flowing through my 5 ohm resistor, right? So since my direction of I2 and I3, which is entering through this V2, so this is minus terminal. So that is why I wrote minus sign of I3 plus I2, right? So this is
Yes, sir.
how we get this equation. Now, is it clear?
Yes. Yes, sir. Thank
Okay,
you, sir.
okay. Okay. So if anyone else has any doubt, please raise your hand. Okay, I hope it is clear. And if it is not clear, you can obviously listen to the this live session also, this recording also later. Now we will be going to the next couple of 4 questions. So we solved what, 7 and 8, and this was 7 to 12. So we are left with 4 more questions. So this is question number 9, right? So they are telling find the electrical power which is delivered or whatever generated by the 2 ampere current source. Now we need to go back. Where is our 2 ampere current source? So yeah, this is our 2 ampere current source. and we will be finding out what is the potential at node 1 and what is my potential at node 2, right? Basically, the potential difference between this node and this node multiplied by the current source would give us what is the power which is dissipated. And if it is negative, so if V1 minus V2 is negative, then my 2 ampere current source would be, the power would be flowing in, so it would be accepting the power, not dissipating the power, right? So that is the convention that we follow. So that is why I wrote. So just be careful. I have used different notations here. This, as you saw, V1 and V2. So this value here, this V1 and this V2, this was written in small v. So these are small v's, right? So this is small v1, small v2. But for denoting the node voltages, I have used capital V1, capital V2, capital V3, V4, so on, right? So just be mindful of that. Be careful of that. So V1, capital V1 is my voltage at my voltage at node 1. V2, capital V2 is my voltage at node 2. Careful of that. Sorry, I didn't write here, but I just told you. So be careful. Okay. So what is my power delivered? So I'm assuming that it is delivering power. We can certainly assume that, right? So it would be nothing but node voltage 1 minus node voltage 2 into my current value, which is 2 ampere, right? Now we don't know what is V1 and V2. Obviously, we need to calculate. So what I did here, so I wrote capital V1 minus capital V3. So basically, V1 minus V3, right? Okay. Uh, Where is 3? Yeah, okay. Yes. So this node, right, between 3 and 1, right, between 1 and 3, right? So what is this? This is nothing but node voltage V1 minus node voltage V3 in this path here. This is nothing but this potential difference or the drop across this resistance, right? So this would be capital V1 minus capital V3 would be small v1, right? This is very simple. We saw in the nodal analysis only, right? So that is why I wrote capital V1 minus capital V3 equals to small v1, and small v1 we just found out it is 20 volts, right? So this is 20 volts. And if we look at node 2 and node 3 now, so node 2 and node 3 is nothing but, so this also we saw. So node 3 is higher than node 2 by how much voltage? By 10 volts, because this plus sign is pointing towards node 3, right? So therefore we will write V2, capital V2 plus 10 equals to capital V3, right? So yeah, this is nothing but, so see here I wrote V2 plus 10 equals to V3. Therefore, see here, what I did, I just substituted V3 in this equation, right? So V3 equals to V2 plus 10, and what I did, I just substituted here. So V1 minus V2 minus 10 equals to 20, right? So therefore, my V1 minus V2 would be what? 30 volts, and I can just replace it here. So this would be nothing but 30 into 2, 60 volts. So therefore, power delivered is 60 volts. And obviously, one more important thing is that, see, my V1 is higher than V2, right? By how much volt? By 30 volt. So therefore, the this this current source is delivering power because the potential at this point is higher than this point. If V2 was higher than V1, then it would have been accepting the power, right? So it would have been different. So minus sign would have been there, right? So this all things you need to be careful. The signs and everything. This is very important while you are solving circuit theory problems. So therefore we get 13 to 2, 60 watts. So this is how we solve question number 9. It is, I hope it is simple. So I'll just stop here and ask you guys, if you have any doubt, please ask. I'll then go to the next question. How I found out V1 minus V2 here, node voltage V1 minus V2 here. So see here, I don't need to find out what is the node voltage of V1 and node voltage of V2, then subtract it. We don't need to find that. Why? I mean, that would be waste of time. we can directly calculate V1 minus V2. What is the value? And then just replace it here. That will do. Simple. So if you have any doubt, just raise your hand. Okay, so I just stopped here because I mean I need to understand whether you understood this part or not. Okay, so since no one has any doubt, and obviously I hope you are able to raise your hand even for those whose mic are not enabled. So people can raise their hand obviously, and I will unmute and you can speak then. I hope you can do that. Okay. So let us now go to the next question. Again, they are asking, find the electrical power delivered supplied by the 3 ampere current source. So what is our 3 ampere current source? This is our 3 ampere current source, right? And my power delivered would be nothing but 4 V4 node voltage 4 minus node voltage 3 into 3 ampere, right? So simple. So this is what I have written: node voltage 4 minus node voltage 3 into 3 ampere, right? Now, in order to get V4 and V3, V4 minus V3, basically we need to solve a similar set of equations. Very small, it would be straightforward. So like the similar problem. Now here I have written V5 equals to 20 plus 20 equals to V4, right? So let's see. So see, V5 is this node and V4 is this node as per my convention. So this is what I assumed, right? So see, so V5 would be what? As I told you, V4 is higher than V5. Potential at node 4 is higher than potential at node 5 by a voltage magnitude of 20 volts, right? So this is what I have written here. So V5 plus 20 equals to V4, and obviously this is okay. So now I am relating node 5 and node 3, right? So node 5 and node 3 is what? So this node basically where this resistance is connected. So basically this would be what? V5 minus V3 would be the potential difference across this resistance, the potential drop, not difference, the potential drop or the voltage drop across this resistance. So using the current convention, you can calculate. Um, See, this would be what V5 equals to 5 into I2 plus I3 plus V3. So we found out that I2 and I3 each are 1 ampere, and we got that, I mean, we are getting that 5 V5 equals to 10 plus V3. Now you can just substitute the value of V5 here, and you will get that V4 minus V3 equals to 30 volts, right? And you can just simply substitute this value here and you will get this value as 90 watts. So this is also, I hope this is clear. I mean the process is same as question number 9, the previous one. I'll again stop here to just see whether if you have any doubt. If you just have doubt, just raise your hand. Okay, so if you don't have any doubt, I hope this is clear. Now, the last two questions, these are pretty simple. Uh, Two questions. So, question 11 says that find the electrical power dissipated consumed in 10 ohm resistance. So, where is my 10 ohm resistance? This is my 10 ohm resistance, right? So, electrical power dissipated means what? This is nothing but your this I square R loss, right? So the heat that is being dissipated, right? So I square R loss, I square I means what? The current I2 is flowing. So this would be nothing but I2 square into R. So R is 10 ohm and my I2 is 1, right? So this would be 10 watts. Very simple. And the last question is the total electrical power delivered generated by the two voltage sources, right? So the two combined. together, right? So this is a combination of two total power which is being delivered or dissipated or supplied, whatever. So these are my two voltage sources, and again I have assumed that my my voltage, the power supplied or accepted, whatever it may be, it is W1, and for my 20 volt it is W2, right? And it is very I mean it is same. So basically 10 watt basically means what is my current flowing through this line here. So this is nothing but I4 minus I1, right? So because as you can see, or I1 minus I4, because see, I mean, whatever you can say, if, whatever you feel, you can write that. So I4 is entering minus terminal and leaving from the positive terminal, and I1 is entering plus terminal and leaving from the minus terminal of 10 volts. So that is why I4 minus I1. And we obviously found out what are the values of this. I4 and I1 we did find out. So I1 was also 2 ampere, and I4 was also 2 ampere, right? So just for your convenience, I'll again show the values. See, it was given, we found out that I2 was 2 amperes, and my I3 was 1 ampere. So I4 would be nothing but 3 minus 1 ampere, right? So I4 would be 2 amperes again. So therefore, these both of these are 2 amperes each. Therefore, W1 would be 0 volts, 0 watt. Sorry. Therefore, it is not dissipating any power or not generating any power, not supplying or not receiving, whatever you may say. And W2 is what? Um, See, W2 is the power dissipated or supplied or generated by this 20 volt source. Now, here, as per this convention of I3, it is entering from this plus terminal and leaving this minus terminal, right? So therefore my is I3 is entering from the plus terminal and leaving the negative terminal. So that is why this minus I3. So this would be 20 minus 20 I3, right? So my I3 we found out. So what was our I3? It was 1 ampere, simple. So this would be nothing but minus 20 watt. So what is the total power delivered? So this is 20 minus 20 watt. So basically this would be, it is kind of accepting the power. It is not delivering the power. It is accepting that power. So that is why this minus sign is there. So, I mean, in your answer, when you are trying to solve the question, you need to put this minus sign here. You just can't write 20 watts. It would mean something else, right? It would mean that it would be supplying the power. You need to write this minus sign here. Otherwise, you won't get the answer. Your solution would be incorrect. So this is question number 12. I hope this was clear. Yeah, 1 minute. Yeah, Arbaz, you can speak. You can ask your doubt. Hello. Yeah, you need to unmute yourself, Arbaz. Arbaz, you need to unmute yourself. Hello. Hello.
Yes,
Arbaz, I
yes,
can. Hello.
yes, sir.
Yeah, Arbaz.
Hello, sir.
Yeah, I can hear you. Please tell. Arbaz, maybe you can write in the chat window what your doubt is. I really can't hear properly what you're saying. There is a chat window here. You can write your doubt there. So if anyone else has any doubt in the current convention or how we calculated the power dissipated, you may raise your hand. You may ask your doubt. We have a time. We have still time. We have time till 9. Arbaz, you can type your doubt in the chat window here. I think there is a chat window you can see. You can access the chat window. You may type your doubt there.
Okay, sir. If I have doubt, then I will just say, okay, sir. You can continue, sir.
Okay, okay. Okay, thank you. Okay. With this, we are done with the first assignment. Now, what we will do, we will solve a small question, right? And at every step, I will stop and I'll just ask you whether you have any doubt or not. So, see, the basic motto of this live session is just not to, solve the assignment questions. I may also give one or two questions, of course, which we will try to solve, and I'll stop at every step and try to understand whether you have understood or not. Okay, so we will start. So we'll for today we'll be just solving one question, and yeah. So okay, so yeah, so I'll just stop my camera also right now. I hope I mean you will be able to hear me. Okay, so for that I'll be pulling up this OneNote screen here, and just if anyone could just let me know, okay, just a minute, whether you are able to see this OneNote screen or not, this circuit which is drawn in violet color. If anyone can just tell me. Okay, thank you. Thank you. Okay, so here this is a very simple problem. We have to find out, I mean, based on obviously based on the problems that would we have looked at. So this is a very simple problem where we need to find out what is the VA, right? Potential across this resistance of 5 ohm using nodal analysis. Obviously, you can solve this using KVL also, but we will solve it using nodal analysis, right? Now we will go on solving this problem. Now what I'll do, I'll just redraw this circuit, right? So just hang on with me. So I'll be just redrawing this circuit. Some guys are still trying to enter at this stage. Please try to, you know, join the session quickly. Really sorry for my drawing. I am not that expert also, so really sorry for that. Right. So this is my one current source, independent current source of 2 ampere. This is another current source of 2 ampere. This is my 1 ohm resistance. This is my 5 ohm resistance, and this is my 4 ohm resistance, and this is another 1 ohm current source. Right now, and color for the benefit of understanding. So I'll be using green color. So I mean, this you can do on your own also. I mean, for my convention, I'll be using this. So this would be 1. Now this would be 2 again, right? This is my 3, and this is my 4, right? This point. Sorry. So there are 4 nodes. This is 1, this is 2, this is 3, and this is 4. So as we saw that we need to, while solving the nodal analysis problem, we need to uh, you know assume a node to be a reference node, right? Or we may we may directly ground it here, right? So my node 4 is my reference node. This is my reference node where my V4 is equals to 0. So this we all saw. I think there is no doubt in that. So what I'll do, I'll try to write each and every node ka equation, and then I'll stop and I'll ask you guys whether you have any doubt or not. Okay. So now let us write what is node 1. So what is this node 1? This is my node 1, right? So here, basically, the main principle of nodal analysis is incoming current will be equal to outgoing current, right? Right, incoming current would be equal to my outgoing current. So what is at node 1, what is my incoming current? This is nothing but this I1, sorry, this independent current source, so 1 ampere, right? So this is our incoming current, and what would be our outgoing current? So one current would be flowing through this path here, and one current would be flowing through this path here. So basically my current would be flowing this way, incoming current at this node, and then it would be going from node 1 to node 2 through resistance of 5 ohm, and from node 1 to node 3 through a resistance of 1 ohm. Therefore I can frame my nodal equation, right? So what would be my incoming current is 1 ampere, and my outgoing current would be what? It would be the potential difference between node 1 and node 2, that is V1 minus V2 divided by the resistance of 5 volts, right? And also the current that is flowing through this path, right? That is node between node 1 and node 3, right? So this would be nothing but V1 minus V3 by 1 volt. Sorry, 1 ohm. So you can obviously solve this. So this would be nothing but 5 equals to your, if I take the LCM and take the 5 on the other side, so this would be equal to 5V1 minus 5 V3 plus V1 minus V2, right? And at the end, I will be getting 5 equals to 6 V1 minus V2 minus 5 V3, right? So this is my first equation. I hope this is clear. So I'll be stopping it here, and I will be, before going to the next node. So I hope this is clear. Pretty straightforward, I think.
Yes, sir. This is clear. Yes, sir.
Okay. Okay. I mean, I can give 1 or 2 questions to you every week for you to solve. I won't solve, right? I will solve it and I'll have the answer, but you can solve it. But what happens is that what we have seen is that in this live session, the number of attendees, so the people that join every session, it keeps on decreasing continuously, and at the end you may have one or two participants who are joining, or some may even not join. So we have zero participants. So that is why what we do, we try to solve these questions on our own, and then we try to ask you live. I mean, we try to solve these questions live, and then we try to ask you whether you have any doubt or not. Otherwise, you can solve these questions on your own only in these live sessions, because this 2 hour session is a pretty, I mean, long time. You can easily solve these and then show the answer.
Sir, one thing is that please these solver question is upload on portal, please, sir.
Yeah,
PDF.
you will get this. You'll definitely get this. Don't worry.
Okay, thank you, sir.
Okay. Okay. So now let us solve this. So next we will have this node 2, right? So we will have this node 2. So what is our node 2? Our node 2 is this node, right? So here, as per my convention, what I'll do is that, see, I'll take that node. At node 2, my current is flowing from 1 to 2, right? So current is flowing in this direction, and also from node 4 to node 2, my current is flowing in this direction. And after that, there is this 2 ampere source, so then current will be flowing from node 2 to node 3. So this would be something like this. So therefore I have 2 incoming currents and I have 1 outgoing current. Therefore I can easily frame this equation. So this is pretty easy. So what we will do is that, see, what was my equation at node at this line? It was very simple. It was V1 minus V2 divided by 5 ohm, right? So this was this current. And what would be my equation at node between node 4 and node 2? This would be nothing but V4 minus V2 divided by 4 volts, 4 ohm, sorry, right? And this would be equal to my outgoing current, right? So this current, basically this current here. So this would be nothing but 2 amperes. So this is the equation. Now we saw that V4 is 0, right? V4 is 0 because this is my reference node, and we need to take this node as one node as a reference node in nodal analysis. So therefore we can easily write this as V2 minus V5 plus 0 minus V2 divided by 4, right? This is, and now we can go on solving this equation. So I'll actually solve this for your benefit, and we'll keep on doing this in every live sessions, right? So we need to take the LCM of this. So this would be what? 4 of V1 minus V2 plus 5 of minus V2, right? And this would be 20, sorry, 2. So this would be what? 4v1 minus 4v2 minus 5v2, and I'll take 20 to the other side. So this will be 40, and so 4v1 minus 9v2 equals to 40, right? So this would be my second equation since I have solved this node. And this is how I solve the nodal equation at node 2. Okay, so now we are left with node 3, and I will again stop here and ask you guys whether you have any doubt at node 2. Okay, yeah, one guy has. Yeah, Saurabh. Yeah, Saurabh, you can go ahead.
Sir, hello.
Yeah, hello. Yeah.
Sir, I'm sorry to interrupt in between this problem, but I was having some doubt in the assignment section, sir, because I, I have seen all the lectures and practiced some of the questions from other books, but the
Hmm.
assignment seems to be too much tough. Like it's not solving. Like I'm not able to solve the assignments. So it's not about this problem, but I was having that problem, so I just thought of asking you, sir. So even after like watching all the lectures, like 8 lectures are there, I have seen all the lectures and few other lectures on the YouTube too. but the questions are seems to be a bit tough. So can you please suggest any other like book or something which can be helpful in this manner, sir?
What is the book that you are following?
So
Textbook?
right now, yes, a textbook. I am having a textbook of circuit theory by Abhijit Chakrabarti.
Okay, so that is, see, that is what the book I was going to recommend only. So, I mean, you can solve some of the problems there. That book has a lot of examples, right?
Yes, sir. Abhijit has a lot of examples. So I tried solving some of the examples and again retried the assignment section, but it was being like I was not able to solve it, sir. That's why I just thought of asking you what should be the right
See,
to
okay, see
proceed.
what you do. See,
Yes,
so since this session can't be repeated, right? I mean, we also
yes, sir.
have work. So what
Yeah,
what you will do is that what I suggest is that I'll be uploading this video, right? You will be getting the access to this video, okay?
yes, sir.
And you can watch this video uh, and try to solve the questions on your own. These questions, these particular questions, and
Okay,
then
sir.
you watch the video, and if you have any doubt, you try to get it clarified by watching the video. Even if it is not getting clarified, you write in the comment section of the YouTube channel, right, of this video, okay?
Okay,
And if you have any doubt there, I'll try to answer right there, okay? I
okay,
mean, by doing that, I hope to some extent this confusion, the doubts that you have, the problems that you have will be solved. And see, this is totally based on practice. The more problems you solve, the more expertise you will gain. This won't come in
yes,
1 day or 2 day. For
yes, sir.
this, you need to solve the that textbook that you are following. That is very good, and I recommend everyone that you can follow that textbook because that has a lot of solved examples. I mean,
Yes,
many
Abhijit
solved
Chakrabarti.
examples you have there. So you please try to solve that, and you can also look at this video. Also try to solve these questions on your own. Obviously, you will have the solution, but you try to solve this on your own. By doing
So
that, of course, some of the confusions you will it will get clarified, and by practice it will improve. Definitely it will improve.
and one more doubt was that, sir. Sir, I was having Sadiko and Abhijit Chakrabarti both. Sir, what do you like? Which book should I refer? I'm actually
See,
preparing for GATE, and which
okay,
book
so
between them, sir?
in
Sadiko and
which
Abhijit Chakrabarti.
year are you studying currently?
Actually, I am pass out, sir.
Okay,
I have
fine,
given
fine,
GATE
fine.
once, just qualified
See,
kind of
see,
thing. Is
see, see. For GATE, I think Abhijit Chakrabarti ka book is more than sufficient. Okay, more than
okay, sir.
sufficient. For GATE, what you need to do, you need to solve the past year's questions. Okay, you need to solve the
Okay,
past year questions on network systems. You need to solve that. And if you want to go a bit higher, once you understand that yes, I am able to solve more and more problems, you can buy a book called Amy, I mean Network Theory by Van Valkenburg. It is a book of a foreign author, so it is a pretty kind of expertise. Once you gain expertise, you can follow that. So there are pretty tough problems in that. But for the beginner level, I suggest you follow the book of Mr. Abhijit Chakraborty, Dr. Abhijit
okay, sir.
Chakraborty.
Thank you very much, sir. Sir, can you please say the writer's name once again, sir? Van?
Van
Yes, sir.
Valkenburg. So see, I'll just type it in
Well,
Google. I hope you can see the screen, right?
yes, sir. I can see this
Yeah,
screen.
okay. So just see Van. Yeah, this book. Network Analysis by. I'll just show this book on Amazon. Yeah, this book. This book. Amy Van Valkenburg. Valkenburg. Van Valkenburg. Okay, this book. This is a pretty hard level problems are there once you gain expertise. Okay.
Okay, sir. Thanks a lot, sir.
Okay, welcome. Okay. Um, okay, so Saurabh, you can unraise your hand. Yeah. So now I hope this note 2, no one has any doubt, it was clear. Now let us solve the last node, that is node 3, right? So just write node 3 here and then I'll go back to the question itself. Yeah. So what is my node 3? Node 3 is this thing, right? So here, see, there are three current paths here, right? So from 1 to 3 there is one, then 2 to 3 there is one, and from 4 to 3 there is one, right? So here, what I'll assume is that all the currents from 1 to 3, 2 to 3, or 4 to 3, they are incoming currents. There would be no outgoing current, right? So this is what I am assuming. Your assumption may be different. That can always be right, but this is what I am assuming. So I am assuming that my current is flowing from node 1 to 3, right? So in this direction. So basically in this direction, node 1 to 3. Then my current from 2 to 3 would be like this, right? And my current from 4 to 3 would be something like this, right? Something like this. So there are three incoming currents, but there are no outgoing current. So that would be zero. That won't cause any problem, right? That is 100% correct. So there would be no outgoing current. So this is what I assume here. So my incoming current from node 1 to 3 would be what? Potential difference between node 1 and node 3 divided by the divided by this resistance of 1, right? So this would be what? um, your V1 minus V3 divided by 1. Now plus there are two more currents. So one is this 2 ampere source flowing from 2 to 3, and another is this 2 ampere source flowing from 4 to 3, right? So this is pretty simple. This would be 2 plus 2, right? And this would be 0, right? 0, why? Because there is no outgoing current. That is why this is 0. So here what we get, this is V1 minus V3, um, and this would be plus 4, right? This would be equals to 0. Therefore, what we can do here, see, now basically we have these three equations, right? Now we need to solve each of them. We need to calculate what is the value of V1, V2, and V3. We have this equation here, we have this equation here, and we have this equation here. So what I'll do, I'll just substitute V3 in this equation, right? So what I'll do, I'll just erase this, okay? I'll just delete this. This is pretty simple. So what I'll do, you can obviously write this as V3 equals to V1 plus V4, right? So this is my equation number 3, right? So what I'll do, I will substitute V3 from 3 in 1, right? So my V3 is this, I'm just substituting here. So what my new equation will be, so 5 equals to 6V1 minus V2 minus 5 into V1 plus 4, right? So this is pretty simple. So just we need to solve this. So this would be nothing but 5 equals to 6V1 minus V2 minus 5V1 minus 20. Now we can just solve this. So this would be V1 minus V2 equals to 25, right? Now we have equation number 4. So we have this, see, we have this equation number 2 where we have only V1 and V2, and we have this equation number 4 where we only have V1 and V2. So now we can easily solve them. So what I'll try to do, I'll eliminate this V1 here. You can also eliminate the V2, whatever you may wish. So what I'll do, see, equation 1 okay, minus this 4 into 4, right? Equation 1 into 1 minus 4 into 4. So just write this equation. So just write the left hand side, 4v1 minus 9v2 minus 4v1 minus or minus plus 4v2 equals to 40 into 1 minus 25 into 4, right? So just let me go a bit down. So this would be this v1, 4v1, 4v1 will cancel. So this would be 9v2 plus 4v2 equals to 40 minus 100. So this would be minus 5v2 equals to minus 60, right? So v2 would be what? 12 volts. Simple. Now we can easily calculate v1 once we have v2. So v1 would be, so you need to substitute this here. So 25 plus 12 volts, right? So this would be 37 volts. And my what would be v3? So v3, where was v3? Yeah, v3 was this. V3 was this equation. So v3 would be what? V1 plus 4. So v3 would be v1 37 plus 4 volts, 41 volts, right? Now we have everything. We have v3, we have v2, we have v1, right? Finally, what they have told us, they have told us to determine what is this value of va, right? So basically, see, now, um, yeah, so basically what would be va? It would be, now there is a confusion basically, that is why I was just hesitating. So this minus sign is there, so this is nothing but they have given to confuse you, nothing else, this minus sign. So what we will do here, we will try to solve this. So what is if I consider the current, so just let me use a different ink, okay, you will understand better. Yeah, so let us just try to consider this IA, right? So, sorry, I. So the current that is flowing through resistance of 5 ohm, right? So current that is flowing through the resistance of 5 ohm in this direction from 1 to 2, right? So I would be what? I am just writing here. I would be what? I would be V1 minus V2 by 5, right? Right, but you see, so according to our I mean this thing, my positive terminal would be here and my negative terminal would be here, right? Because my current is entering through the left side and entering through the exiting through the right hand side, right? So that is why I have chosen this to be plus thing. But as per the question, this is just the opposite, right? So my va would be 5 into minus of I, nothing else, right? Because this is plus as per my convention, right? But here this is opposite, right? This is minus here, plus here, nothing else. So that is why this minus sign is here, nothing else. So this is pretty simple. So I'll just stop here. Once I finish this, I'll just stop and ask you guys whether you have any doubt or not. So I hope this is clear how I achieved this. So what would be my VA, right? So this is minus 5A. So as we found out, VA would be minus 5I. So what is I? As we found out, it is V1 minus V2 by what was that? 5. 5 volt 5 ohm resistor, right? So this is nothing but 5 gets cancelled. So this is V1 minus V2. So what was my V1? This was 37, as we found out here, 37, and this is 12. So this is minus 25. So this would be my answer, final answer. This is what they told to find out, right? What is the value of VA by nodal analysis? So this is how we find out what is the value of VA. So I hope this was clear. If you have any doubt, just raise your hand. This was a pretty simple problem. I hope this was clear. If you have any doubt afterwards, okay, yeah, Himanshu, go ahead.
Sir, in this question,
Yeah,
sir, we look node 3.
node
Sir,
3. Yeah,
node 3, yes, sir. Sir,
hmm,
यहाँ पे at node 3, 2 ampere and 2 ampere both are incoming.
yes.
So then I take, sir, in 1 ampere, the 4 ampere is outgoing, 1, 2 or 2 incoming, then 4 ampere is outgoing, and node 1, 4 and 1 incoming. Then, sir, I try to in node 3 at 5 ampere side. So directly, sir, 5 ampere is incoming. Then I also get the 5 into 525 and opposite the direction because of the plus and minus is opposite sign. Then this question is solved it easily because without any equations.
Surely, see, surely you can do that. See, it is as per your wish. You can try to solve this as quickly as possible. The main motto is
Yes, sir.
that
Thank you,
using
sir.
nodal analysis, you need to arrive at the right answer.
Yes, sir.
Whatever you choose.
Okay,
See,
sir.
what I did at note 3, what I did, I assume that all the currents are incoming, right? What you can do is that you can
Yes,
consider that, you know, let me just choose a different color here. So what you may do is that you may choose that, okay, fine, this current would be outgoing. So therefore your nodal equation would be
yes,
something like this: 2 plus 2 equals to V3 minus V1 by 1, right? It is the same as this, right?
yes,
If you
yes,
just take
yes,
it is same, right? So it's as per your
yes,
convention.
yes, sir. Sir, then I take, sir. So
Okay.
the current the current between node 3 and node 1, then, sir,
Hmm.
you take V3 minus V1 upon 1. Yes, I
Hmm.
directly wrote the V3 minus V1 upon 1 is equal to 4 ampere. So then, sir,
Hmm.
direct 4 ampere is coming
Hmm.
from node 3 to node 1. And, sir, and we look down that circuit, the node 4 and node 1. Between node 4 and node 1, from node 4 to node 1, 1 ampere is incoming. Then, sir,
Hmm.
from node 1 to node 3, 4 plus 1, directly 5 ampere is flowing from node 1 to node 2. I directly find the value of I 5 ampere.
See, I understood, but it is better for you. How do you know that 1 ampere is directly flowing into 5? 1 ampere may also flow into 1 ohm resistor, right? It is a potential divider. 1
Yes, sir.
ampere may flow into 5 ohm resistance. 1 ampere may flow into this path, right? It may also flow to this path. You can't take,
Yes, sir.
see, 2 ampere is directly flowing through to 1 ohm resistor, that I agree, but 1 ampere may flow
Yes,
to 1 ohm also, and also to 5 ohm, right? So you can't directly
yes,
take that to be 5,
yes.
it would be wrong.
Okay, sir.
You understood? Because this is a potential, this is a divider circuit, this is a potential divider circuit.
Y-
1 ampere is
Yes, sir.
getting divided into 5 and 1, you just can't take that. So
Yes,
there you will be wrong.
yes, sir.
You'll arrive at the wrong answer.
Okay, sir.
You
Now
understood,
clear,
right?
sir.
Yeah.
Yes, sir.
Okay. Okay. Yeah.
Thank
So
you.
yeah, it is good that you are asking this question. So I mean, other people will also, doubts will get clarified. Yeah. Yeah, Saurabh. Yeah, go ahead.
Yes, hello.
Yeah.
Yeah,
Sure.
so I was asking, can't we just
Hmm.
use a current divider rule over here and find VA?
See, it is difficult. Yeah. See, how will you? I mean, see, through 1 ampere, 1 ohm resistor, your 4 ampere is coming, right? As he told, as Himanshu was telling that at this node, 4 ampere is flowing into 1 ohm. Again, 1 ampere is also flowing, it is getting divided into 5 and 1, right? So you don't know. I mean, it would be difficult, right? If there was no 2 ampere source, then you would have easily applied the current divider rule. the potential divider, whatever you may say, and then calculate what is the current flowing through 1 ohm resistance and 5 ohm resistance. But since you have two other current sources, it would become complex. So that is why the best thing is that you use nodal analysis or KVL to solve this kind of questions.
So I was saying now that see, we have 2 ampere and 2 ampere, two current sources over here, right? So the
Yeah.
thing is that it, the 4 ampere source is going to come to node 1,
Hmm.
and the 1 ampere shows the 1 ampere source which is here is going to cut the 4 ampere into 3 ampere, right? And after that 3 ampere we can divide. Is it valid? I am not sure that is this method valid. Can we do?
Um, See, you can always practice that, right? At your own time, you can always practice that. I think it may be valid because 1 ampere current source is not dependent on a 4 ampere
Yes,
source. So you may directly apply the potential divider rule here and then find out what is the current that is flowing through 1 ohm source, 1 ohm
yes,
resistance, right?
yes,
Yeah, you
because
can
I
do that. You can do that.
okay, okay,
I
so
mean,
yes, so,
yeah,
and
tell.
so the this session recording is going to be uploaded on the YouTube or on the sir portal, NPTEL portal.
See, I'll be uploading this session on YouTube and I'll be sharing the link with NPTEL. They will be sharing that link with you. So you can directly access. And once you access that, you will be getting my YouTube channel, right? So you can directly access my YouTube channel after that and see the videos.
Okay, sir. Thanks a lot, sir.
Okay. Okay. So, yeah, so that's it for this session. I'll again just turn on my camera. Okay, so yeah, so that's it for today's session. We'll be again meeting next week, and we'll be trying to solve this, assignment too. And this is my just a suggestion that this is a very, good course. This is a very scoring course. So please, and this is a very basic level course which you require afterwards in every aspect. If you are an electrical engineer or electronics engineer, you will require network analysis at every stage of your life. So please try to understand the concepts and try to take this course as a fun course. So I mean, it would be very fun. The more you practice, the more knowledge you will get, and you will be more enthusiastic that अरे यार मुझे और भी problem solve करना है, ठीक है ना? So, I mean, have that mentality and proceed, you will do well. All of you will get good marks. So, these materials I will be giving, and I hope this will help you. Yeah, Saurabh, go ahead.
Sir, last question, sir.
Yeah.
I was saying that the course which domain course which is there for VLSI,
Hmm.
like
I
can this course help me getting into the domain certification for enough for that, sir?
could
I
you
was
repeat?
having a
Could
dilemma
you
about.
could you just repeat? Your voice was breaking. Again, just
Okay,
repeat the
sir, I
point.
was asking
Yeah.
that we have a domain certification on VLSI by NPTEL,
Okay.
right, sir? So I was thinking of preparing for GATE and side by side doing this domain certification because like the subjects are same, uh, but a little difference is there. So is this domain certification enough for getting into the industry, or do I need to have a proper training from some training institute or something? What would you
Uh,
suggest in those terms, sir?
See, NPTEL certifications are accepted by industries, but I don't think, just registering for a course and solving weekly assignments would help you in that. You need to be trained. I mean, you need to physically conduct the experiments also. I just don't think, solving, registering for a course would be sufficient for that. You need to have
Okay, sir.
experience also.
Hmm.
Yeah.
Okay, sir.
Okay. So, okay, fine. So I'm just stopping my screen. So we will be again meeting next week. That is Monday on 13th, I guess. Yeah, 13th February 2023 from 7 a.m. to 7 p.m. Sorry, to 9 p.m. And we will be solving assignment number 2. Okay. And meanwhile, you go through this video. If you have any doubt, you please comment on the comment section of the YouTube channel. I will definitely try. Okay. Thank you. Thank you, everyone. I'm ending the meeting. Yeah, it's 9. Thank you.
Thank you.
Thank you, sir.
Thank you.